Hello everyone, welcome back to another video. Today we'll be starting with deep learning. Now, before we dive in, quick note is this course is designed for people who know Python. So like you understand loops, functions, maybe you've played around with NumPy or even some pandas as well. You don't need to be like a Python wizard or something in order to follow through this course, but I would assume that you would know some kind of basics of Python. Now, over the next few videos, we'll be going from what is a neural network, uh, what do you do with neural networks, what are classifiers, what are chatbots, and we can even use generative AI that can create art. So we'll go through all of that in such a way that it'll actually make sense. Now, deep learning, mostly when I see people try to learn it, they usually try to learn it in such a way that they try to build something very quickly and try to get the concepts crammed in their brain. But I don't think that is the right way you can learn deep learning. Whatever you want to learn, it is better if you try to get the proper intuition behind it and try to learn why we are trying to do it before you learn it, so that you'll be easily able to understand whatever you're trying to achieve. So yeah, we'll try to do all of that. We'll try to not only just solve maths equations, but uh, we'll try to solve it in such a way that you guys understand and figure it out easily on your own. So we'll just take a step forward and we'll just take a look at what exactly is this deep learning. Deep learning. Now, sounds like a big terminology, right? What is this deep and why are we calling it learning? Now, what exactly do you mean by learning? Learning is something which humans usually do, right? What is learning? You'll try to recognize something, you'll try to think about something, and try to come up with a proper explanation to anything, something. So, normally in programming, the rules are like this. So, if you were to identify, like, let's say, an email, whether it is a spam or not a spam email, you would typically, if you were told to just write a normal code to it, you would just see for certain words like lottery, let's say, or you would see for words like congrats, any word like this. You'll see if these words exist in the email, and if they exist, then it is a spam, else it is not a spam. Now, this is a classic if else condition, right? Now, we can tell that this is a rule. Okay, so traditional programming, mostly the humans, whatever they write, they try to figure out each problem in terms of rules. Okay, and in this way, we'll be able to gain some kind of output. But do we truly learn from this case? Do we truly learn what a spam email is? In this case, if you make sure that this is always following some rules. Let's say in the future, if instead of congrats, the person starts writing congratulations, the full word, and instead of lottery, he'll say some other thing, casino, some other thing. So in that case, your program did not learn from it. What it essentially did was it just followed the rules that you have written down through this and made sure that you got a proper output. Now, what is learning? Learning is something in such a way that when you look at a few samples, you should be able to take a newer sample with you and then see whether that is proper or not. See whether that is spam or not. In this case, it is spam or not. That case, we'll be using something called as learning. Now, what exactly is this deep learning? Now we got some idea of what learning means, right? In deep learning, we'll see what this deep means. Okay. Now, what exactly do you mean by deep? Deep is something which has a lot of depth. Okay. Something which has a lot of stuff in it. So we'll take like a simple example to, see and understand this deep concept. So let's say you have like a transparent filter. Okay. Let's say you have like a transparent filter through which only certain kind of light can pass through. Okay, so let's say you have a filter with red. Okay, so through this filter, if you take a look, only red light can pass through. Okay, and we'll take a similar example. Let's say there is another filter, and through this, only blue light can pass through. Okay, so if you overlap these both together, okay, on top of each other, you'll notice that both red light and green and blue light, both of them can pass through. through these filters. Okay. So, and this is usually how the three-dimensional 3D perspective works. You have a red filter and a blue filter, and you overlap them within two of your eyes, and then you'll be able to see the picture properly. So, let's say there's another filter. You overlapped another filter through which only, like, let's say green light can pass through. Okay. Or you overlapped an other picture which through which, let's say, some other light can pass through, some yellow light can pass through. Now if you take a combination of all these pictures, you'll see that you are able to see red light, blue light, green light, and yellow light, all of them together. But if you take one of these layers and you are able to see through that kernel, through that filter, you'll be able to see that you are only looking at one kind of color. If you take a yellow filter, you'll take a look at only one yellow color. If you take a green filter, you'll take a look at only green color. So individually, they are contributing to knowing a certain kind of color. But together, they are contributing to learning something which is big, learning colors of whatever you're trying to see. So this is basically synonymous to the concept of deep. Now, deep here talks about the number of layers. Now, what are these layers? Are these the color layers? No, not exactly. So, we'll think about this in the communication perspective, in the email perspective. So, the email here, if you're trying to classify whether it is a normal email or if it is a spam email, you might have many things which you need to think about. What are they? You might need to think about, let's say, certain keywords like lottery or congrats, or some other group of keywords which can see whether, let's say, it is saying you won a lottery, congratulations. The sentence on a whole, it might be there, some other reasons as well. You can correspond it to here in such a way that one layer, one color filter will be able to identify all the different words which correspond to a spam email. The second layer, you might be able to see that whether the combination of the words will result in a spam email. Or the next layer, you might be able to see that whether the overall structure of the email looks like a spam email. Okay. So if you put all of these layers together, you'll be able to see, you'll have something like this. Let me just draw it in a new place. You might have something like this, something like a group of filters which you have. Okay, so where one filter would be able to classify whether it is like some words. Let's say it checks for words which says lottery or something similar to lottery, or some other one which says whether it is saying congrats. Okay, or some other thing which checks the structure of the structure of the email. So it might happen, right? So when you pass in your email through these layers, I mean, when you, let's say this is your eye, you're trying to look at the email through these layers, what will you be able to see? You will be able to easily identify whether this email is spam or not spam. Deep means you're utilizing multiple layers of singular features and trying to combine them and try to see or learn something. Now, this is called as deep learning. What exactly do we mean by deep learning? We mean that we are trying to have multiple layers in our system, trying to learn one feature at a time and make sure that the output, whatever we are trying to give, is as generalized as possible. Now, we usually do this by something called as a neural network. Now, what is this neural network and all? We'll keep going there. But I just want you guys to have a basic meaning, basic understanding of what this deep learning means. Okay. So, why is it called deep learning? Because there are multiple networks, multiple layers. Okay. And each layer will recognize different features. It might recognize different shapes, it might recognize different objects, and so that it can build up the understanding of whether an email is spam or not spam hierarchically. The mind blowing part about this is the same technique, neural networks, it works for many different problems. So imagine you have a cat photo, or if you want to train some model which can recognize whether a photo is of a cat or is it of a dog. This is my impression of drawing a dog. But if it is a cat or is it a dog? Or translating different languages. You can have a network trained which can translate French to Arabic or something like that. Anything. So neural networks is like this. It's like we found a universal learning algorithm, and it usually works for everything. That's enough theory for now. I'll show you what deep learning can actually do. Okay, so I'll I'll show you some fun activities which you can try out so that you'll be able to play with deep learning. All right. So here we are. This one is called Quick Draw. This game is made by Google, and here you can draw anything, and the neural network will try to guess what you have tried to draw. Okay, so we'll just play a few rounds of this so that you guys can have a clearer understanding. So it's telling me to draw a squirrel under 20 seconds, and it will keep trying to guess that whatever I'm trying to draw. So you guys can see. I'll try to draw a squirrel. Okay, so let's see, maybe something like this. Uh, Maybe something like that. And I think this would be the tail. Oh, see, it was able to see that it's a squirrel just from that crappy drawing I drew. And it's asking me to draw a boomerang. At the bottom, if you noticed, it is trying to guess whatever I'm trying to draw. So let's see, boomerang. Let's try to draw a boomerang. Okay, it's seeing a line, it's seeing a mountain. Oh yeah, see, as soon as I drew this, it's just saying that it's a boomerang. Broccoli. Okay, let's try to draw broccoli. I would imagine something like this. A nose. Okay. Green bean. Trombone. Oh, it's thinks that it's a mushroom. Pliers. Okay. I don't. Okay. It it was not able to identify that it was a broccoli. I mean, that was a pretty bad broccoli, anyways. It's telling us to draw a spider. Okay, let's try to draw a spider. Let's give it two eyes. Uh, and give it several legs. Yeah, see? And campfire. Okay. And a map. So I think I can draw the Dora the Explorer map as well. Maybe some kind of this. Okay. Never mind. It was not able to guess my map or my broccoli. But you can see, you can click on different images you have drawn. So let's say broccoli, and yeah, see, it thought my drawing looked like more of a brain or an elephant or an umbrella. But broccoli, I think it would have recognized by drawing something like this. This is what other people drew for broccoli. And I still believe that my broccoli looked way better than these. So, and what about the map? Oh, you can see it thought it was an oven, or it thought it was a dishwasher or a soda can. I don't know what made it think that it's a soda can. Maybe this one it thought it was a soda can. But yeah, I mean map like this would make sense. Mostly there were X marks on the map, so maybe it was thinking that it was a thing. So yeah, you can see nobody programmed that this application should predict that something is black by just looking at it. Okay, there's countless examples in here. If I just draw a banana, nobody predicted that a banana should look like this, right? Because people look at that, people easily are able to say that it's a banana. How do we make sure that a machine who has nothing to do with it is easily saying that it's a banana? Okay, now this is another cool project. Okay, so this is also made by Google, and through this you'll immediately be able to find the proper and be able to train a model instantly in your browser. So we'll just take an example, an audio project. So we'll just speak something, okay? So let's just say that, okay, okay, so we've recorded like 20 samples of background noise. But here you can see, we can probably, try to let's say we'll try to make like a classifier which can classify whether I'm talking or whether I'm singing. Okay, so we'll try to do that. You can watch me sing as well. So I'll name this singing, or I'll name this talking. Okay, so let's just try to sing. There we go, those are my singing. I will not show you those because those sound horrible, and some talking as well. Boom. So now my singing and my talking ones are done. So if I click on a train button here, it is training the model to identify whether I'm singing or I'm talking. You can see, there we go. And I think now if I just keep talking, I think you will be able to see that it's increasing the talking score a lot. But if I start to sing, you can see that my singing score is going up. Now, this is not perfect. You can see whatever I'm trying to do here, it's not perfect because there's some background noise, some kind of singing, some kind of talking. But you are able to see, I'm able to train a model which can identify whether I'm talking, now whether I'm singing or whether I'm dancing. So you're able to see that those fluctuations are there here. So I hope you guys are not too scared of when I'm singing. So yeah, that is that. That is another cool example whether you can you know train the neural network. But if I stay silent, look at it. Looking at, did you look at the background noise? So it's seeing whether I'm talking or whether I'm singing. So if we had more proper data, you'll be able to see that it will be providing much better output as well. So yeah, so this website is called thispersondoesnotexist.com. Now this person entirely does not exist. Okay, this is not a this is not a real human being. This face was generated entirely by AI. Now again, details of it you'll know later. Generative adversarial network. So every time I refresh this page, I'll get a new person, a new person, a new person. None of these people existed at all. This is what I mean when I say deep learning is, changing everything. The same technology that powers this is powering most advanced structures like Dolly or ChatGPT images or Nano Banana, all of these. So you see the detail. You can see the hair of the person. You can see the lighting. Uh, doesn't look like a computer generated photo at all. So we've seen some impressive demos, but let's be real about what deep learning can do and what it can't do because there's a lot of hype out there. So let's see what deep learning can do. Deep learning, we will be able to use deep learning in stuff like computer vision. You'll be able to use it in natural language processing. You'll be able to see and analyze speech and audio with it. We've seen this as well. And you'll be able to create different games you can provide games or you can, improve your strategy. That is also there. And, mostly pattern recognition or generative tasks, etc. You'll be able to try to do them. But deep learning still struggles when there are some things. Okay. So, you've seen a lot of LLMs and stuff. They are smart, they look smart, but they usually act upon data which they already know, but they don't seem to understand and understand the cause and effect the way humans will. So they'll fail at simple logical problems. And it is very bad at making sometimes it is very bad at making decisions. So they'll tell you that this is a cat or this is a dog, but whether or not like what to do to make a cat into a dog or something like that decisions, it is very hard to do that. And I think it is very bad at creative reasoning as well. But it doesn't come up with new concept, it will just use an previous concept and try to come up of a generalized solution from that. So yeah. So where are we going with this, boot camp? And we'll start from scratch. We'll know what is a neural network. We'll know how you'll build a neural network. Okay. And by the end of the first few classes, you'll be able to have you'll be able to train and deploy your first image classifier, and we'll go deeper into optimization algorithms, overfitting, or the practical skills you would need to know. We can then slowly move on as we go on, as the series gets more and more reception. I'll try to move on to computer vision or the transformers, generative AI, or how to make different RAG systems, etc. and etc. So yeah, those are all the things which we'll try to learn in this boot camp. And I think I'll tell you now is the perfect time to learn deep learning because previously deep learning was very hard. You needed very so many GPUs. You had to write everything from scratch. Frameworks were clunky. It took forever to train anything. But 5 years ago, it was slightly getting better. And TensorFlow, PyTorch, but you still needed some decent hardware. Today, it's like easy. It's very easy. You can train models in Google Colab for free with GPU, and you can fine tune state of the art models as at the comfort of your own laptop. So yeah, I mean, the documentation is everywhere. The frameworks are very intuitive. The community is massive, and the demand is also insane. Every company is trying to integrate AI. Every startup is building with LLMs. So the job market for the people who actually understand this stuff, it's not just API users, but just people who understand the fundamentals. The market is on fire. So yeah, uh, you can't just use ChatGPT and you call yourself AI engineer. You need to understand how this stuff actually works, how to train the model, how to debug them, how to perform well, how to deploy them, all of this. So I think those are the things which I'll concentrate more on this while I'm trying to go through this course. So yeah, this is what I want you to do after this video. I want you to go play with these demos, especially the teachable machine one, and actually train a model yourself. You'll get the feeling of, whoa, I just trained an AI model by myself. And to make sure that your environment is ready, you would probably need Google Colab and stuff. If you have not done it already, we'll cover this briefly in the next videos, but be mentally prepared. And the third most important thing I would say is I would want you guys to get excited. I know I keep saying this, but deep learning is the most exciting fields in technology right now, and you're learning something that is actively changing the world. So, yeah, in the next video, I think we're going to set up our environment, we'll train our model, we'll take a look at some more stuff. But until then, I think that's pretty much it. See you later.